Last lesson, we have learned that although usually the vertical axis is y and the horizontal axis is x, but actually the vertical axis and the horizontal axis can be something else instead of x and y. The question is, why do we want to make the vertical axis and the horizontal axis into something else instead of x and y? This is because when we make the vertical axis and horizontal axis into something else instead of x and y, we can make a non-linear graph into a linear graph. Let's look at this example. Here we have this equation y equal x squared and its table of values. If we plot the value on the graph, we have this curved line. However, we can also plot y equal x squared on the graph in another way. We are going to change the horizontal axis to x squared. In order to plot this new graph, we need a new row for the table of values. We need a row for x squared. Right, 0 square is 0, 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16. So now we are going to plot these values on a graph with y on the vertical axis and x squared on the horizontal axis. When x squared is 0, y is 0. When x squared is 1, y is 1. When x squared is 4, y is 4. When x squared is 9, y is 9. When x squared is 16, y is 16. So now we have a straight line. We can convert most non-linear graph into linear graph in this way. One more example. This is the table of values for equation y equal x squared plus 3. If we plot the values on a graph, of course we will get a curved line. But then we can make it into a straight line by making x squared the horizontal axis instead of x. Let's do it step by step. First, we have a new row for x squared. And the values are 0, 1, 4, 9, 16. When x squared is 0, y is 3. When x squared is 1, y is 4. When x squared is 4, y is 7. When x squared is 9, y is 12. When x squared is 16, y is 19. And then we draw a straight line. The gradient is 1. And the y-intercept is 3. So the equation for this straight line is y equal x squared plus 3. We have seen how we can make a non-linear graph into a linear graph. The question is, why do we want to do that? One of the reasons is that it's easier for us to find the value of the constant in an equation from a linear graph. We have seen how we can do that. But we are going to look at one more example. Another reason is that it's easier for us to make projection from a straight line. Now let's look at the following two graphs. One graph is y equal 6 over x plus 2, and the other is y equal 4 over x plus 3. They look similar. If we are not told which is which, we actually cannot tell. And if we are not given the constants, these values beforehand, it is hard for us to find this value from the raw x and y data. But if we change them into straight lines, we see what happens. We are going to change the x at the horizontal axis to 1 over x. So we are going to have a new row of 1 over x. So when x is 1, 1 over x is 1. When x is 2, 1 over x is 0.5. When x is 3, 1 over x is 0.33. When x is 4, 1 over x is 0.25. Now we are going to plot the graph for the first one. But we need to change the scale for the horizontal axis to from 0 to 1. When 1 over x is 1, y is 8. When 1 over x is 0.5, y is 5. When 1 over x is 0.33, y is 4. When 1 over x is 0.25, y is 3.5. We join up all these points and extend the line to the y-intercept, and then we find the gradient of the graph. The gradient is 6. Intercept at the y-axis is 2. So we get the equation of the graph y equal 6 over x plus 2. Let's look at the next one. When 1 over x is 1, y is 7. When 1 over x is 0.5, y is 5. When 1 over x is 0.33, y is 4.3. When 1 over x is 0.25, y is 4. We join up all these points and extend the line to the y-intercept. And then we find the gradient of the graph. The gradient is 4. Intercept at the y-axis is 3. So we get the equation of the graph. Y equal 4 over x plus 3. So we can see that by plotting the data in a straight line, we are able to find the values for this constant.